Hi everyone. Today I'm going to introduce a chemical engineering product. It is Go nanoparticles. First of all, this is my graphical abstract. This is what I'm going to talk about today. First of all, I'm going to introduce the properties for important properties, and I'm going to introduce the applications that can be developed regarding the four properties, and followed by the two ways of synthesis. These are my contents. As I mentioned, I'm going to introduce the properties, applications, and followed by the ways of synthesis. And at last, I'm going to convey some of my own thoughts. Let's make a really brief introduction first. Gold nanoparticles are small gold particles of diameter 1 to 100 nanometers. Its property widely diverges from bulk scale gold material. It's about 500 cells in 1 nanoparticles and 4 atoms per cell. So you can calculate it's about approximately it's 2,000 atoms per nanoparticle. Next, it's the properties. First property is among all noble metal nanoparticles, for example, copper nanoparticles, silver nanoparticles, platinum nanoparticles. Gold nanoparticles can be considered as the most stable one. And second is its excellent biocompatibility. It's because of the SPR. SPR stands for surface plasmon resonance. It's the fluctuation and interaction of electrons between negative and positive charges at the surface. Its excellent biocompatibility allows it easy to functionalize with biologically active organic molecules. So it is readily conjugated with recognition moieties such as antibodies. And the third property is it has unique optical property. It absorbs light with extremely high frequency. As you can see here, it's a graph of wavelength, but you can calculate the frequency through V equals to lambda f. And property 4 it has unique X-ray absorption coefficient. And here are the applications it can be developed regarding the 4 different important properties. First of all, it's the stable property. It can be prepared with various shapes and structures, as you can see here. Nanosphere, nanoshell, nanorod, cluster, and whatever, and also over here. These are drug delivery carriers that enhances therapeutic efficiency. And application 2 regarding the excellent biocompatibility, they can be used for viral detection and diagnostic application for disease such as cancer. They inject the gold nanoparticles in the spot that may be suspected that have disease. It's declared here as the red spot. And the application 3 is treating cancer. They inject the gold, it's a long story, but to make it short, they inject the gold nanoparticles in the place that there is cancer cells, and energy is transferred to the gold nanoparticles, and gold nanoparticles release a special heat energy, and it kills the cancer cell. And application 4 is the thing that we are familiar with, everybody must have been known to this one. It's the CT imaging, known as computed tomography. And here comes the ways of synthesis. It's mainly 2 ways. It's top down and bottom up. From its verbal meaning, you can know top down is from big to small, like from big to small, and bottom up it's from small to big, like from atom scale to nanoparticles. And for top down, it's, for example, it's sputtering and laser ablation. Here are the examples. The pictures regarding the two ways of synthesis. And for bottom up, I'm going to introduce it like precisely in this area. There are three ways of synthesis. First of all, it's the physical approach, as you can see here. It's from atom to cluster, and cluster self-assemble to nanoparticles. And the second way is the chemical reduction of metal ions from solution. It is retained by introducing a chemical agent. We don't have a picture here. The third one is the biological approach. You extract the gold nanoparticles from plant. You can see it from this picture here. Here's the exact process. And here I'm going to talk about my own thoughts. Apparently, gold nanoparticles consist of many useful functions, and the ways of synthesis, you cannot say it's cheap, but it's relatively cheap to other like very expensive processes. However, the raw material is gold, so it's quite expensive, so it's not a way of treatment that ordinary people can be used, so it's not really widespread. I hope like from the development of technology, the method of treating cancer can be widely spread, so less people can be suffering from cancer. They can use the treatment using gold nanoparticles. That makes it really efficient. And here are my referencing articles. Thank you for watching and listening. Thank you, everyone.